All right, so it's quarter past now, so I suppose we can get started. We have maybe a few people that are still going to join us. We're expecting maybe 10 people total, so most of you are here. And I know there's at least a few local people that are going to kind of come and go to different parts of the course. So yeah, I had the overview up for what we're going to cover today, and we'll go through that in just a moment. But yeah, I figured we could probably start with some general information about the course, like who we are. So I think for short courses like this, it's always nice to introduce one another, since you're going to be sitting in the same classroom for 5 days together. It's probably you're going to have a chance to talk to the person next to you from time to time. So, and yeah, I don't know. I'm going to start, I guess, with myself. So my name is David Whipp, and I'm an associate professor here at the University of Helsinki in the Department of Geosciences and Geography. And my kind of scientific areas of expertise are in geodynamics, mainly focused in the lithosphere, and how geodynamic and geomorphic processes interact with one another. So looking at how erosional processes at the surface can affect the geodynamics of mainly modern active origins like the Himalaya and Andes. And so as part of this, when I was a PhD student, I did quite a bit with low-temperature thermochronology. And so I'll be contributing in part to the course, mainly at the end for the numerical modeling of low-temperature thermochronology data. And then I guess in the back of the room we have the other person listed here.
Yeah, my name is Jim Walker, and I'm professor in geophysics here. And I have been working with geothermics. That means geothermal heat flow measurements, calculating temperatures of the crust and the lithosphere for quite a number of years already. And that's one kind of a special field for myself. And of course, all the measurements we know about the temperatures come from boreholes. So borehole investigations is close to my field of interest. And however, as we're working in the sheet area, where most of the thermochronological work is related to finding out the age of the rock, so crystallization age, granites, etc. what we have here. So that only a few hundred kilometers to the west of us, we have a quite nice range of mountains, the Scandis Mountains, the Caledonian Mountains, which have very nice high topography. And there must have been quite some changes in the surface topography there that shows very recently. And then the question is that how does this actually affect our areas here? And that's one of the kind of questions I wanted to ask the people that as we are living here in a shield area, so when did the shield become a sheet? So when did the exposure of these rocks come to the surface? They have been metamorphosed at about 500, 600 degrees and 5 kilobars. 50 kilometers of rock at least being exuded away. So how did we come to this final situation? And this is kind of fields of questions I'm interested in. And I hope we will have an interesting meeting ahead of us. No. So, please.
Yeah. So yeah, so Ilmo and I sort of arranged the course. And I think the sort of stars of the show are going to be coming in the middle of the week, and those are the invited speakers that will be here on Tuesday, Wednesday, and Thursday. And I guess they'll probably introduce themselves, so I didn't prepare anything to. So I guess probably everybody's seen the course webpage at this point. I'll just show it here. So, there's not much there right now, just the same general information that was in the emails, basically. But I think the plan will be that as we go day by day, we'll just add lecture material there. So right now I'm recording what I'm saying here. The hope is that we'll record all the lectures, and so we'll put the slides up, but we'll also have a recording of what was presented. So, if there's anything you want to go back and revisit, you can. I also had requests from several people that couldn't attend the course, asking whether we were planning to record anything, and so we're going to try that and see how it goes. And essentially, you'll just see, like, I'll add a day one link over here once the materials are available, and I'll just post everything to the web page. So when we're all said and done, we should have essentially everything that we deal with will be available for you, and for, if you have colleagues or friends who are interested, you can just, the website's just going to be open to anyone who wants to use it. So yeah, but that's it for right now. There's not a whole lot there. The one thing I do want to say something about is the software and kind of computing environment we'll use for the course. There's lots of different ways we could deal with software in this course. I've opted to go the route of installing or basically distributing an image of a virtual Linux machine. So essentially this would be like running an operating system within your operating system of your computer. So it'll be like having a little Linux machine in a window. And the reason for doing that is that I can basically set up all the software in advance. It's all installed, and I don't have to worry about like people who are using Windows and different versions of Windows and Mac and different versions of Mac OS and all the kind of compatibility problems that can come up. I guess we've already had one issue with downloading the image. It's quite big. It's almost 9 gigabytes. So I have it on the hard drive here. If you couldn't download it, we'll distribute that just manually. But what I wanted to do just quickly here, since I didn't actually have the virtual machine set up on this machine, is I was going to show you how to do the configuration. It doesn't take much, but just so that we can see it here, everything is kind of set up, but you have to, when you get this image, you have to tell VirtualBox how to use it. And so I think I'll just set that up because I was going to demonstrate on here anyway how the system works. So I've downloaded VirtualBox and it's up to date. And the way you go about using this disk image or operating system image is you can click the new button here. It'll ask you for some name. It doesn't matter what you put here. I'm just going to put Low-T Thermochron, whatever. And then you're asked which type of system it is. I'm going to select Linux, and it defaults to Ubuntu 64-bit, which just happens to be what we're using. So yeah, and I'll go through this maybe a little bit quickly now. If you have questions and want to tinker with this stuff, I think there should be time before lunch. I tried to not have too much material this morning so that if we want to get things set up, we can do that. It recommends that you use 1024 megabytes of memory. I'm going to double that just because. Yeah, just because. And then I just hit continue. And now the key thing here is I want to select to use an existing virtual hard disk file. So this is the thing that you just would have downloaded or copied off this external hard drive. And I have it right now on my desktop in a directory called Low-T Thermochron. And here it is. So it's just this Ubuntu file. When you hit open and then create, now the system is all sort of configured and set to go. And yeah, essentially by clicking start, I'm just going to turn the power on this computer. And if all goes well, this should operate exactly the same on any one of your computers, regardless of what operating system you have. I assume no one's running anything where VirtualBox is not available, like some weird, I don't know, even probably Solaris, you could still get this. So there's a password. It's Thermochron 2017 with an exclamation mark, and that's on the website, so don't worry about it. But basically, it's like logging into a regular computer within your computer, and depending on how fast your machine is, it might be a little bit slow, but I find it's actually quite usable. I mean, like Ubuntu is not super heavy in terms of resources, and you can make it full screen and things like that. And essentially now it feels like you're just using this other Linux machine. There's already a directory here with course materials, and inside there's already some stuff, different pieces of software that we're going to use that some of the other instructors have sent me and had me sort of configure. So yeah, everything should be here, and it should work just like this for you. It's just a matter of getting this disk image, so we can do that maybe before lunchtime or during one of the coffee breaks or whatever. So that's that. Does this idea of the virtual machine make sense? I guess like some of you have probably already done this. Like I know they do it for some of the computing courses here, that you use a virtual machine so that everyone can have the same system, whatever. It's nice because you can do things like pause it, which essentially just suspends the computer, and then you can pick it up, you know, right where you left off. I'm just going to leave it paused here in the background and go back to what we're doing. Yeah, so we could install the software other ways too. If you want to talk about it, we can do it kind of individually, but I can tell you it's going to be a little bit of a hassle if you're a Mac user, because some of the software is Windows-based, and that can be a little bit tricky to do. So we did our computing demo. All right. So a couple other things, and then we'll actually get into some real stuff. I guess you've probably read through the course goals in the emails from before, but basically we want to introduce low-temperature thermochronology and the kind of general ideas of what is a thermochronometer, and a bit about heat transfer processes in the crust, because as you can tell from the name alone, temperature is going to be very important in understanding thermochronometer data. And our sort of invited lecturers in the next 3 days are going to focus on giving us a bit of detail about argon-argon, dating fission track, and then also uranium, thorium, helium in that order. So we're going to go from high temperature to low temperature. And you know, we'll get varying levels of exposure. I think it's planned on Wednesday, for instance, that you'll actually look at some images of apatites that have been etched in acid to enlarge the fission tracks, and go through the process of like counting the tracks and kind of see, you know, what that's like. And then, you know, during most of the lectures, we'll have some opportunity to play around with some different computational tools. So that could be like playing in Excel, or using some software that already exists for doing some kind of thermochronometer analysis. Or like Friday, we'll focus on doing 3D thermal modeling with this P-Cube software that is, you know, can be quite powerful. We'll set up some simple models to learn how to use it, but you know, it's quite a robust and powerful piece of software. So that's what we're headed at, and you know, our desired outcomes here in terms of what we'd like you to come away with is that you can at least explain the concept of thermochronology and how it's applied to study tectonic and erosional processes. Maybe say something about these different thermochronometer systems. So we might expect that you could, you know, say something about what the argon-argon system is based on, how it works, and some of the practical issues related to dating with the argon-argon method. And also be able to use different pieces of software. You know, you're not necessarily going to be an expert in any of them, but at least you'll know how they work, and you'll feel like, okay, maybe I feel confident enough that I can go forward and apply some of this software in future research or whatever. And I think we've already kind of covered that we're going to use a combination of lectures and computer-based stuff. Today will be a little bit lecture heavy, and then as the course proceeds, it'll get a little bit more of a balance between exercises and lecture. And one other thing here of the kind of boring stuff, in terms of credit points, you can get 3 credits basically just for coming to the course, as long as you're here more or less every day. There's not so many of you, so we can kind of easily keep track of who's here and who isn't. You'll get 3 credits that way, and we'll talk about this kind of individually at the end if you're interested, but you can get an additional 2 credit points if you want to take something we've done and then go and do some sort of small project. So like if you learn the P-Cube software and you want to go and then take some data that we can give you and make a P-Cube model to interpret the data, we can do things like that and you get a couple extra credit points that way. That's not really very well defined, but we can talk about that possibility. I think it's, for me at least, that's kind of a nice thing to really be able to apply what you've learned. All right, so yeah, here we are, basically 9 to 12-ish. We're going to, from here on, talk about basics of thermochronology and then a little bit of some different applications. We'll have a lunch break from noon to 1, and then in the afternoon, Ilmo's going to talk about crustal thermal processes and some previous studies of low-temperature thermochronology in this part of the world. And otherwise, our schedule is kind of not so different from what's on the website right now. So I won't say much about this because the other speakers and other teachers will cover these things. But again, we're just going to do argon stuff on Tuesday, then fission track on Wednesday, uranium, thorium, helium on Friday, and then some numerical modeling, uranium, thorium, helium is on Thursday, and then some numerical modeling on Friday. So that's kind of where things are going, and here's a pretty picture because there weren't any pictures for the last while. So I know that was kind of the boring stuff. Now it's out of the way. Are there any questions?